Hey, folks.
Hello.
Got one more. I don't suspect that many people are going to be in this today because it's the first one. Okay.
Yeah, I was concerned I wouldn't know how to work Zoom, so
So you check.
so
Well,
I checked.
the UI is changing on a daily basis right now, which I don't necessarily blame them for because their user base is like 600 times what it was a month ago. And so they're trying to respond to feature requests as quickly as they can, but it's not
God, I wonder what their stock looks like right now.
easy. That's a good question. They're probably doing great stock wise, but their engineers are so stressed out.
Yeah. Well, that's what I've heard. I've heard system engineers are and like admin support are the most stressed out right now.
Yeah, because they're having to kind of keep things afloat. And then the problem, like the minute your site becomes that popular, it becomes a much bigger target for hacking, which means that any vulnerabilities that weren't a big deal before suddenly become a big deal. And they weren't expecting that to happen this quickly. So,
Is that why there's this whole password thing?
yeah, there are a number of security features that have been rolled out recently, but there are also a lot of people like complaining on social media about how you should get off of Zoom because it's got all these security flaws. And it's like, well, the problem is it's the pandemic apocalypse and people don't have an alternative right now. And so, as much as I love the concern about security, the thing is there's not an alternative that's more secure because
Yeah.
Google Hangouts is decidedly less secure. And so,
Yeah.
like, between the two, the security vulnerabilities on Zoom allow people to show up and like pour and bomb the Zoom, but the security vulnerabilities in Google Hangouts allow hackers to like get all your personal data. So between the two, I'd rather the first, you know?
Yeah. Yeah, that makes sense. There's also what, Microsoft Exchange? Is that what it's called?
I think so, yeah. But they're very big on locking people into accounts, which makes it tough.
Yeah, that makes sense. I gotta say, I'm loving working, doing class from home.
Oh,
I'm just
yeah?
like I'm sitting in my bed right now. It's awesome.
That's nice.
Yeah.
That's good. It's I don't know, it's going to be an interesting quarter. We'll see.
Yeah.
A lot of the course activities rely on, well, not rely on, but were designed for in-person interaction. And so we'll see how they translate to the online format. I'm sure some stuff will have to change, but we'll see.
Because you taught iOS development a
Yeah.
couple of quarters ago, right? Is it similar material to that, or?
So the scope of the iOS API that we discussed has been pared way down because we'll also be going over the Android API. But the chief purpose of the course is less the individual APIs, because the thing is, one, the APIs change. So if I teach you the API, then everything that you learn in this class is outdated in a year. And two, the API is Googleable. And so if you understand the basic principles, like I've been a professional code slinger for years, and when I need to look up how to put an on-screen alert on iOS, I Google it. I don't, you know. And so as long as I know what I'm looking for, as long as I know what's available and what I'm looking for, that's more important than memorizing the individual APIs. However, the skills that kind of underlie that, the skills of debugging and architecting and building robust software and managing versions and that kind of stuff, that applies to any software stack. We happen to be doing it on iOS and Android for a couple of reasons. The first one is that it's new to everyone, and so nobody's starting with like, we're not starting with these big disparities and who knows what, because everybody knows either no Swift or a little Swift. So that's not a big disparity to deal with, which is nice. And we don't have to unlearn any bad habits in a particular programming language. So that's the first reason. And the second thing is that we'll talk about this more during the actual lecture, but in mobile development, you hit limits that you don't hit in other programming paradigms, in like console programming or when you're building a server. However, those limits, they exist everywhere. They just happen to be lower in mobile development. And so we'll get the opportunity to grapple with how you manage a small amount of space and how you manage an extremely flexible UI and that kind of thing. because those will also be valuable on other stacks, but it's just more pertinent that you be good at them in a mobile environment, because you're working with a very small computer that is very versatile in the way the UI should be. I'm going to turn on some lights here. I think I have a better lighting solution. Let's see. Okay. Is that better? Yeah, that's marginally better. My house is not built for being a classroom. It's not built for any of the things it has to do right now.
Yeah. Same.
Okay, we got some more people, right? Angela, Lauren, Frederick.
Hi.
Hey.
So I saw that you used to work at Pivotal Labs, right?
I did.
I used to be a client of Pivotal Labs.
Really? Which company?
Yeah. In New York. I was at JP Morgan.
Okay. Yeah, we had some people come to Chicago from New York for a while.
Yeah, it was great. I loved being there. I was there for 6 months actually, because it was supposed to be like a 12-week project that got extended over and over.
Right. I feel like that's how most of them end up. I don't think I was ever on a project that was supposed to be 3 weeks that ended up actually being 3 weeks. Software just takes longer than that.
Lauren, were you at Grace Hopper last year?
I was, yeah.
I thought I recognized you from the MPCS article they sent out.
Oh, yeah. That's embarrassing. They always want me to be in articles for some reason. But I don't mind, but
yeah. I'm hoping to do it. The application comes out like soon, right? Like April.
I don't know. I wonder whether they're even still going to have it this year.
It's a good point. Hopefully this settles down a little bit by October, but you never know.
Yeah. So were you able to apply with the school?
No, not yet. They haven't sent anything out. I talked to Beth, who I think was also in the Grace Hopper last year, and we
were roommates.
Yeah, she said it was really fun. And then also like Sarah, who I think is the TA for this course, she did it, and they all said it like the application came out early spring quarter.
Yeah, that sounds about right.
I tried to just like go online and see if I qualified outside of UChicago, but I don't. I'm not. Yeah.
I'm relieved that the password system is working for everyone. Apparently there had been some issues with it.
I didn't have to enter a passcode.
Same.
You didn't?
Yeah, neither did I.
No.
And it's not working at all.
No.
Oh no!
Too well.
Every time I have to join one of these, they give me a password and I've never had to use it.
It's not even, are you kidding me?
No.
On none of that. So here's why that's funny, is because I use my Zoom account also for like some various team meetings for the sport that I do, and some like social things with people who do the sport that I do. And they've been like hamstrung by some of the security stuff. So it's funny that when we actually need it, it's not working. Although I think I don't think it was the password. I think the waiting room, they were surprised at the waiting room.
My last class that I was in, she said that there's apparently a thing called like Zoom bombing, and that she was like, in case somebody Zoom bombs with porn, like I'm going to drop the call and then I'll have to resend everyone a link. And she's going through this whole thing. And she's
no, you can just remove people.
Well, I don't know. She said that like she was just going to send out a new link, because then they can easily just join again.
They can rejoin unless, so there's a setting in Zoom where you can say don't allow people to rejoin who you have removed.
But if they know the link, then they can.
But they can't rejoin now. Well, they could, I guess, rejoin from like another email address.
Yeah, I don't know.
I don't know how that would work.
She said, and she's like, I don't bomb like their porn with my lectures, so they shouldn't bomb my lectures with their porn.
Flawless logic. All porn bombers will hear that and immediately be like, oh, duh, I don't belong here. That's how that works.
I
Man,
thought it was a
if
fun
we could
one.
trust everyone on the internet to be good, so many people I know would be out of a job.
That's
Like
true.
every security engineer I know would be out of a job. I gotta admit, this is higher attendance than I expected for the first social.
Chelsea, what sort of tea did you go with this time around?
This is Moroccan mint tea from Numi. I get it at Target.
Ooh, caffeine or no caffeine?
No
What are you
caffeine.
doing?
No caffeine this
Okay.
time. It's a little late in the
Not
day.
at this hour.
No, yeah.
Yeah.
Because I got to get to bed early. But it's a really good one. Highly recommend. But I am in a tea group. So I have a little group of friends. And every month we send each other like some tea that we've been enjoying lately.
Oh, that's fun. There
Yeah,
you go. Cool.
it's super nice because they're all way more like educated about tea than I am. And so I just send
Sure.
something that I've found, and they send really nice stuff. So it's probably bad, and I'll probably eventually get kicked out, but I've been enjoying it.
Have you ever gotten any like homemade chai or anything like that? What's been the top pick?
Let's see. Somebody sent me some rose tea recently that was really good, and I still have some, but it's really caffeinated. And so I don't drink caffeinated tea that often. I'll drink coffee on training days, decaf tea on non-training days, so I don't have opportunities to drink.
Sure.
I don't know. Are you a tea fan? You drink a lot of tea?
I've been switching over to tea recently. Did for a while. Was on the matcha kick for a couple of months, but left my matcha in the city when I fled to my parents' place in the suburbs. So I'll have to try to find a way to get my hands on some more.
How many of y'all are still in the city? A few. I'm still in the city. I know a few people had to go home. We've had folks go home to all kinds of all over the country, all over the world. So it's going to be an interesting class. We're going to try to run it because we've got people like 13-hour time difference from us. And so
yeah,
we're going to have to try to make as many of the assignments asynchronous as possible. So we'll see how that goes. It's going to be a wild quarter, y'all. Sarah, how are you?
I'm good. I'm sitting on my patio because it's
you
lovely
look like
out.
you're in the wind.
Yes, it's like the most pleasant temperature.
It's really nice out. I'm really worried that Lori's going to take away all of our outdoor privileges after today.
I went on a quick walk and there were a lot of people congregating in the park by my house, so
we're gonna
not good.
We're gonna get light booted out of every single park. It's over. It's over for us. Have y'all seen those memes, the Where is Lightfoot memes? They're really, I can't stop laughing at them. They have the mayor of Chicago photoshopped into like various empty scenes, giving that death stare she's so good at. But they're pretty awesome. They asked her what she thought of them, and she said that she really likes them.
You need a mayor with a sense of humor in these times.
Yeah, she does. And she did that little infomercial where she tries to play the guitar and rearranges her pillows, and it's all very personable and fireside chatty. Which is nice. I'm surprised at the enrollment. We have 22, but we had 13 like a week ago. So let's see. Are all of y'all's teachers using Zoom, or is there a variety of stuff being used for video conf?
I've only seen Zoom so far. I think that seems to be the standard.
Yeah, so U Chicago gives us a Zoom account, which is nice. So that I'm sure has something to do with it. But it also seems to deal a little better with the latency than Google Hangouts does. Yeah. All right, let me do one last check to make sure that everyone who's responded to the student info form has access to our GitHub repo or GitHub organization. One more. All right, I'll add this person and we'll let people trickle in for a minute or two, and then we'll get started pretty quick because we got a lot to do, but I don't want to cut y'all's breaks short if I don't have to. Okay, is it Zealand? Did you just get access to the GitHub organization?
Let me check.
Is that how I pronounce that?
Just submit the form. Let me check.
I hear my computer fans going. Apparently 20 people is the point at which it needs those. I don't know why. All right, it looks like we got almost everybody. I'm gonna go ahead and get started. I suspect that y'all already know a lot about how to use Mute or how to use Zoom if you're using it in all of your classes. But we'll go over a little bit more of the etiquette for it in our class. But for now, I'm gonna go ahead and have everybody mute. And I can mute, there we go. Are you ready to get started? So first, let me go ahead and show you where our GitHub repo is because I want you to have access to that. Or rather our GitHub organization. So we have a GitHub organization. Let me share my screen with you so that you can see it. This one. Can y'all see my screen? All right, fantastic. So let me do this. Perfect. All right, so feel free to unmute if you have questions or anything as we go through this, but then just mute again when you're done asking the question. So this is our GitHub organization, and you'll see in here a repo called Session 1. The slides that I'm about to go over are in the lecture notes, which you can click on right here so that you can follow along.
Is anyone else not seeing the session 1?
Yeah, this is Nick. I don't see any repositories. It just
Right.
says your team doesn't have access to any repositories.
Really? All right, well, let me see. If I can figure this out. Manage access. That looks right. Who has access? Okay.
Chelsea, I think if you go back to the previous page, and under manage access, a second, on the right-hand side, you haven't added any teams or people. I wonder, since it says your teams don't have access, if you have to add like the MPCS team.
Oh, you may be right. No base role set, only owners with direct access. All right, do I have to make a team? This is, okay. Can I add everyone? This is gonna be in, okay, here we go. All right, now let's see if I can add people to the team. I hope it lets me do this in bulk. It's not gonna let me do this in bulk. Okay, this is what we're gonna do. I'm gonna make this repo public so that we can get started, and then later I'm gonna go back and try this team adding situation. How does that sound? Because this repo doesn't have any proprietary information. Probably shouldn't auto. Okay, can you see it now? Yes?
Yes, I can see it.
Yes.
I got it. Yep.
All right, fantastic. All right, so if you have questions throughout this time, feel free to either unmute and ask them or drop them in the chat. But while I'm looking at my screen, I'm not super good at seeing questions in the chat. So feel free to let me know if you see a question in the chat and it looks like I've just been ignoring it. But let's go ahead to, so the lecture notes are available. And then the thing that we're going to be looking at in the lecture notes first is going to be this slide deck right here. We all good? Okay, so welcome to mobile software development. This is, you've read the course description, but we'll go over a couple of things right now. I want to go over what we plan to cover in this class and what sort of the course goals are and that kind of thing so that you're clear on all of that ahead of time. What happened to my cursor? This is much harder than it should be. So first of all, who we are, I'm your instructor. My name is Chelsea Troy, and I'm a professional software engineer. I've done iOS programming, Android programming, a whole bunch of other stacks. I've written about 13 languages to prod at this point. And so we'll talk a little bit about what that means for this course later. My office hours, you'll get this on a later slide, but my office hours are going to be on Saturdays from 3 to 5. And then I can make time outside of that if you need it. And then we have your lovely teaching assistant. Sarah, do you want to introduce yourself?
Yeah, hi, I'm Sarah. I am also a software developer. I work at Groupon now, but I just finished this program in December. So haven't taken this course, obviously, because it's new, but I took a lot of the mobile courses. So hopefully it'll be a good time.
Cool. So that's one thing I do want to stress about this class, but as we get started, is that this class is a brand new class. You're actually in the very first run of this class. It was kind of just designed, and when we were initially planning on running this class for the first time this spring, we weren't actually expecting to also have to do it in the first quarter that the entire university was remote and there was a pandemic happening all around us. So it's going to be an extremely experimental quarter, I think, for all of us, which is something to keep in mind going forward. I've made a couple of adjustments to the course to handle the remoteness and to help to some degree, I hope, with the stress that people are experiencing right now. I know that some of you are staying home with family, some of you have elder dependents that you're taking care of, some of you have kids that you're taking care of, and other obligations going on. So I'm going to do my best to make this course as accessible to you as possible. And this is going to be sort of, trust is going to be the name of the game for this quarter. And my hope is that you will trust that we are doing our best to deliver the material to you as effectively as possible. And we'll ask you to kind of do your best to participate and engage with us and let me know what's working and what's not working. Cool. So let's talk about who you are. The current enrollment, when I made this slide, it was 20, now it's 22. But I sent you a course survey to ask you a couple of questions about yourselves. It turns out most of you are graduating this spring, so this is your last quarter, if I understand correctly, in the master's program. Congratulations. I'm sorry that convocation got canceled, but we'll figure something out. And these are the programming languages, if y'all have written before. Some of you mentioned a couple of other programming languages, but I kept the ones here that multiple people have responded to when I looked at it. So the vast majority of you have written some Python. A whole lot of you have written some Java, and then after that, some JavaScript. We've got a couple of others in there, C++, Scala. A couple of people talked about some other programming languages, HTML, CSS. I think we got one from Haskell, a couple of other things like that. But most of you have little to no experience with Swift and or Kotlin, which is actually a good thing going into this course. We'll talk about that a little bit later. Okay, so you are from, among other places, China, Japan, Singapore, Mexico, and the US. I suspect it's more places than that. I didn't ask a specific question about this, but some of you mentioned it, so I thought I'd throw it in here. Several of you are business students hoping to build software companies, and some of you want to build software for education or gaming or healthcare. A couple of you mentioned other things that you want to do as well, which is really cool. Some of you I know have full-time jobs in addition to the program, which you might be doing full-time or part-time. I know some of you have kids at home. I know at least one of you has a Shiba Inu puppy. Is that accurate? Somebody mentioned a puppy in the survey.
Yeah, that's mine.
So we're gonna have to see pictures of that puppy at some point, right?
Sure.
Okay, good. So you have a pretty diverse class here, which is pretty exciting. And one of the things that we go to a university to get is the opportunity to build relationships with other people who are not necessarily like us, but who share some of our interests. So in the interest in keeping that part of the value of the master's program, I thought it would be good to do that kind of social 30-minute period before class. You are not required to come, but hopefully you'll find that valuable. So here are the important times. We went over this a little bit. Session is on Tuesdays from 5:30 to 8:30 Central. If you are here, this is not new information. My office hours are going to be on Saturday afternoons. You should have received a Zoom link to that in your email. Sarah's office hours are going to be on Mondays from 6:30 to 8:30. We have a new Zoom link for that, so I'll send that out via email after class. And then the social chat. Cool. So let's talk course goals real quick. Because the goal of this course is called Mobile Software Development. But the goal is not to develop fluency in the Android or iOS APIs specifically. The reason for that is twofold. First of all, the APIs are they change pretty fast. So as the versions of Swift go up, as the versions of iOS go up, or as the versions of the Android system go up, or Kotlin, the APIs will change. If I teach you specifically the APIs and just have you memorize APIs, then about 12 months from now, your skills on iOS or Android would be obsolete unless you had deliberately kept up with them. So that's the first thing. The second thing is that API-specific stuff is really, really Googleable. So I've been slinging code professionally for years, and if I need to add an alert dialog to an iOS app, I don't have memorized what the code is to do that. I go and I Google it. And that's the way that things are going to be for any stack that you're writing for the majority of your software engineering career. So my goal is to give you the skills of software engineering that are one level deeper than Googling a specific API. So Those skills are going to help you. They'll help you in Android and they'll help you in iOS. But those are examples that we're using in this class. You could use these skills on a Python stack or a Java stack or a Ruby stack or what have you. So those, well, let me go over a little bit what those are going to be. So we're going to talk about things like version control. We're going to talk about debugging. We're going to talk about what it means to build resilient software. We're going to talk about architecture choices and making it so our program doesn't crash as often, or it communicates effectively with other programmers so that they can maintain it after we leave. We're going to talk about navigating documentation. We're going to talk a little bit about programming language design. So these are things that apply on any stack. All right. So why we're using mobile development as the example. If we could use any stack as the exemplary stack in this course, why these two? The first reason is that most folks are new to it. So that means there's not going to be a big disparity in the class between who knows what. If we used, for example, Java, we would have folks who knew a whole lot of Java and folks who were brand new to Java. And in this case, the difference is people who know a little bit of Swift and people who don't know Swift. So having that relatively small disparity means that we have the opportunity to focus from the beginning on what it would be like to build our knowledge of a stack in the professional world. The second reason is that in mobile development, you grapple with limits that you don't hit with console computing or web app development. So in contrast to the computer that you might be watching this on, a device like this has a lot less memory. It has a lot less reliable access to data, say via the internet, depending on where you are, if you're moving around, those kinds of things. And you also need to have a really flexible UI, because your UI can go from 200 by 400 to 400 by 200 in a second, completely flipped. And your app still needs to look good. It's pretty rare, even in a browser application, that you're going to see that disparity in the type of screen you're looking at, even if you're trying to make a responsive design. So when you think about these concepts in the context of mobile development, you will be over-prepared for them on other stacks. And they're going to include everything from accessibility to data privacy to computing limitations, data limitations, sourcing ethics. There'll be a few throughout the quarter that we'll talk about. All right, so grading. This is the way the grades are going to break down, and I'll go over what each of these means. So the first one is participation is going to be 30% of your grade. There are two parts to participation, and all of the participation in this class can be done either synchronously during session or asynchronously outside of session. And the reason for that is that if somebody is in a time zone that doesn't work for the class and they need to not attend session, they'll still have the opportunity to get full points in the participation arena. In addition, people like to contribute in different ways. So we might have a discussion, let's say, about our ethical responsibility as software engineers. We'll have an in-class discussion where people will have the opportunity to talk to each other about something that they've read. So we'll take time in class to do that. It should be an interesting activity and you'll learn a lot from talking to your peers. But there will also be an issue on GitHub for the session where we're doing that. And people will be able to comment on that issue either during or after class in order to sort of log their participation in that discussion. And then if you're somebody who feels like you can communicate your thoughts better via writing than in person, that's one way that you can get that participation. Or you could, take advantage of the class time and we'll still have those discussions in person if that's how you learn best. The second part of participation is going to be surveys. So like I said, this is an experimental quarter, which means that we're going to be trying a whole lot of techniques that some of them may work and some of them may not work at all. In order to determine throughout the quarter what is or isn't working for you, I'm going to be sending you surveys to ask you to choose between two alternatives for the way that we've tried something, or to ask you for your responses to the way that we've handled the course discussion or something like that. These surveys, I'll give out the links, but you can complete these either during class time that's set aside for this or after class as well. So any participation points you can get in one of those two asynchronous ways up to a week after class. It'll be due essentially at the same time as the homework for that class. So that brings us to homework. There will be homework for this class. There will be a couple of different types of homework that you can do, but I do want to say something about homework ahead of time, which is that our approach to homework in this class is going to be a little bit different than the approach to homework that you may have in most master's program and computer science classes. A lot of the master's and computer science classes give you a lot of homework because they're training you with volume. You need to write a lot of code to get comfortable writing code. In this class, most of you are graduating. You've already had the volume training. In addition, we're in kind of an unprecedented time right now where a lot of people have responsibilities outside of learning that they don't necessarily have during a normal quarter. So for that reason, I'm trying to think really carefully about the homework assignments and determine how to deliver the maximum value to you with less of a time spent on homework than you might spend in a typical MPCS class, not during a pandemic. So my goal is going to be to keep the homework under 6 hours a week, most weeks, which I understand is different from the minimum 10 hours you're sort of expecting in most classes. That having been said, when I send you a survey and I ask you how long the work has taken, I do want you to be honest with me. If it only took 30 minutes, that doesn't mean that you did it wrong. The reason that I need you to be honest and tell me the amount of time it took, even if you think it's not a lot of time, is because if it's taking everybody more time than that 6 hours to cumulatively complete the homework, then I know that something might be out of whack. So I'm pre-testing all the homework assignments with a couple of different people. I have some people doing pre-reading for me, some people doing pre-coding to tell me about how long these assignments are taking them. But I do want to check with those surveys whether there's a discrepancy there. So that's why I'm going to be asking those questions. So don't feel like you need to round up or like exaggerate the amount of time that you took, or else I'm going to like give you more homework. That's not the goal there. So what kind of homework am I going to give you? We're going to cumulatively build at least one app over the course of this quarter. So for example, for weeks 2 through 5, we're going to be cumulatively building one iOS app. And then after that, I'm not sure what we'll do, but I think we'll be cumulatively building one Android app. The reason for that is that I want to keep that homework volume low, but I still want you to be able to walk away with a project that's complex enough that you would be able to use it as a potential portfolio piece if you needed to show an employer that you know how to code. So that's why we're doing it that way. So you may receive a specific feature challenge for your application as homework. You'll also get critical thinking and writing assignments where there will be a reading attached. So essentially this will be a series of questions. And I'll give you 1 or 2 reading materials that you can use to inform your answers to those questions. The goal here is not to go back to elementary school and do these reading comprehension assignments where I'm putting these questions together to be the police and determine that you like read the thing that I asked you to read. The purpose here is that these are things that it's really, really important for software engineers to think about. They're things that you're going to want to have thought about when you get on the job. And so that's what those assignments are for. The second one, or the third one, is small challenges in apps that I give you. So there may be a situation where I want you to practice a specific debugging skill, but that debugging skill isn't necessarily relevant to the application that you are cumulatively building. So in those cases, I may publish a repo with some starter code, and then you can pull down that repo with the starter code and practice the debugging on the starter code. So that's homework. The reason I keep looking over here is because your faces are over here. So I'm trying to gauge confusion. All right. So then projects. We're going to do 2 projects in this class. The first one is going to be a presentation on an open source application. In that project, essentially, I'll give you links to several open source apps that you can choose from. Most of these open source apps will be more complicated than the thing that you are building during the course. But the idea is that you will also build the skills throughout the course to look in those apps and understand how they work. So you'll do a presentation on one of those open source apps where you talk about a feature of that application and how it was implemented based on your perusal of the code. That's one option. The other option, if you're more interested in the design than the software engineering, is that you can talk about how that app conforms or doesn't conform to the design guidelines for that application. So if you pick an iOS app, then you'll talk about how it conforms or doesn't conform to the Human Interface Guidelines, which is a set of guidelines that Apple publishes. It's colloquially called the HIG. In Android, they also have guidelines. They're called material design, so that's what you would use for an Android app. We're going to go over this in more detail later. You're not ready to start worrying about the presentation yet, so just don't worry about it for now. Second, the second project is going to be a video walkthrough of the app that you wrote cumulatively in this class, why you chose to write this specific app, and any part of the code that you are proud of. So, as an example, we're going to be going over testing methodologies in this class. Believe it or not, if you demonstrate that some software that you wrote has tests, that's going to get engineers' attention at potential employers, because a lot of applicants are not going to have done that. So this is a graded assignment, but this is more for you, really, to have a video of yourself walking through your app, because it's more likely that potential employers will watch a short video of you talking about your software than it is that they're actually going to pull down your code and scour through it to see what you know. Are there any questions so far? Feel free to unmute if you have a question. All good? Okay, I'm gonna move on. So how it's gonna run. So every session is gonna be, the first thing I should mention is that every session is gonna be recorded. The reason for that is so that people who can't show up during the normal class time will be able to watch the class. So your face will be recorded, your voice will be recorded. However, those videos are not going up anywhere public. They're going up on Panopto, where only University of Chicago students will be able to see them. By contrast, I will record and send you some videos to watch outside of class. Those videos are going to be of me writing code in iOS or Android for you to follow along. Typically, we would do this in class, and we will still do some live coding in class, especially for the first couple of sessions. But the idea of making these videos is to free up some class time for us to do in-class exercises, or to have question and answer periods, class discussions, ways to keep things a little bit more interactive. Because it's going to be really tough to sit in front of your computer for 3 hours and just watch me talk. I'm not that interesting. I'm interesting, but I'm not that interesting. All right, I already mentioned this. The plan is to keep homework under 6 hours per week, most weeks. You also have 2 free 24-hour extensions. So if you can't get the homework in by exactly the deadline, which is always 5:29, right before the following class, then you can take a 24-hour extension. Just let Sarah or myself know that you're taking it, and we'll mark it. You can use it. You can use both days for one assignment. You can use them on different assignments. We don't care how you use them. This is us trusting you to know when you need some extra time. Outside of those 2 free 24-hour extensions, I don't grant additional extensions. The reason for that is that I want to be fair to folks who come from all different educational backgrounds. A lot of folks, like growing up, for example, me growing up, I couldn't have asked teachers for extensions because I grew up in like a disciplinary educational background where they were more focused on like keeping us quiet and in the room. And so this is a way to equalize that playing field. So you get 2 free ones, and then after that, no. All right. Academic integrity. I suspect that you have all heard about this because we are required to discuss it in the first session. But I do want to go over this a little because this class is a little bit of a special case, I think. And the reason this class is a special case is that I've designed this class specifically based on my experience with what computer science graduates come out of the program and have trouble with in the professional world. I've hired a whole bunch of people over the course of my career. Many of them came out of graduate programs and engineering programs, and there is a pattern to what they struggle with when they get into a professional context. We're going to go over a lot of those things in this class because I think that that's going to put you in a much better position to have a lot less stress going into more advanced, higher responsibility positions in the software industry. I think of what we're going over in this class as essential knowledge. So if you turn in somebody else's work as your own and you bypass obtaining that knowledge, one of two things is going to happen. The first one is you'll get caught. You do not want this. You do not want an assignment to tank your grade. You do not want it to jeopardize your opportunity to graduate. But you've already heard that speech. The second thing that could happen is you won't get caught. And believe it or not, you also don't want this. And this is why. Is it right now you're in this class where you're expected to make mistakes, where there are no professional consequences for making mistakes, and where Sarah and I have been specifically drafted and paid to answer all of your questions without judging you. So you could turn in someone else's work as your own, you could bypass the skills, and you could go get your job without knowing them. And then in a professional context, we're expected to know those things and paid to know those things and given health insurance on the assumption that you know those things. And you have a product manager breathing down your neck and a deadline that's supposed to happen to you. And you don't have me or Sarah anymore. That is a much less comfortable time to realize that you don't know something. So I'm mentioning this because, like I said, this quarter is going to be a little bit trust-based. I'm not like trying to take points off people. I'm not trying to fail people. But with that trust, I'm expecting y'all's best effort. And I suspect you understand that it's also in your best interest in this class and in all classes to put that best effort forward. All right. So that's the end of the sort of course overview. Are there any?
Kelsey, quick.
Oh, yeah, what's the question?
There was a question in the Zoom chat about the 24 hours can be taken on 2 separate assignments, right?
Yes, they can be taken on 2 separate assignments. Let me see if I could stop. Did I stop sharing? What happened? Y'all can see all of yourselves now, right? Okay, cool. I don't know why I'm having so much trouble with this. All right, were there any other questions before I move on? No? We're good? All right, so here's what we're gonna do. We're gonna take a 12-minute break now so that you can get food if you need to and do what you gotta do. And then at 6:14, we're gonna come back and keep going, okay? Fantastic. I'll see you in 12 minutes. Welcome back. Can everybody hear me okay? Rock on. Cool. So we're running a little bit ahead, which is actually nice and uncharacteristic for me. But what that means is that if we need to slow down a little bit on anything, we can. And if we don't need to slow down on anything, then we can start talking a little bit about Git at the end of this session. So we'll see if that happens. But first, we're going to talk a little bit about programming languages. So specifically Swift, but first we're going to talk about programming languages in general and some of the characteristics of programming languages. So I think I accidentally provided a little bit of a cheat list on this one, so I'm sorry about that. But when you think of characteristics of programming languages, what do you think about? You can type in the chat what you might think about. So one might be just an example, functional versus object oriented. That might be example of a characteristic of a programming language, right? What else might be? Static versus dynamic typing. Yep, that's a good one. We'll talk about that a little bit. In terms of, it seems like what people know is Python fundamentally functional or object oriented, do you think? Ideas on that one? What's Python? Does Python have a paradigm chiefly? Primarily functional? All right, interesting. How about static versus dynamic typing in Python? Plain Python, not MyPy.
It's dynamically typed.
It's dynamically typed language. Is it so interpreted versus compiled? So this is an interesting one. Which one do you suppose, or how do you think of Python on this one?
Python's interpreted.
Okay, so this is an interesting one because the way that we think about interpreted versus compiled is not necessarily what interpretation versus compilation is. So the answer in Python's case is actually both. It's an interpreter and it also has a compiler. So a compiler chiefly is taking a programming language and it is converting it either into another programming language, so we call that transpiling, or into machine code. It's compiling down to machine code that we might run on a specific device, or the vast majority of programming languages now, their most popular interpreters compile down to be run on some kind of a virtual machine. You may have heard of the JVM, the Java Virtual Machine. Whole lot of programming languages now compile to work on the Java Virtual Machine. It's the same in Python. We have a virtual machine that it compiles down to chiefly. An interpreter will do that compilation and then it will also run it. So many interpreters have a compiler in them, and in fact, in a programming language, whether it is what it is compiled to is more a function of the particular compiler you're using than it is of the programming language itself. So for example, in Python, there are, it can be converted into bytecode and then from there go down to a VM or to a specific, to specific machines. But there's PyPy, which does it down to C rather than straight down to the VM. Or in Ruby, we have interpreters that generally, the most popular one compiles Ruby, or rather, yeah, compiles Ruby down to C and then runs it. It's interpreted. Or in JRuby, it goes down to Java. So Fun fact about compilers and interpreters there's a really, really good book called Crafting Interpreters. It's by Bob Nystrom. I'll give you the link to some of that in the additional resources after class. But if you're interested in having compilers and interpreters broken down in a really understandable way, he does an absolutely excellent job. He worked so hard on the book. He did all the illustrations himself. Apparently it took him 5 years, but it's an awesome book. So compilation and interpretation, great. So yes, Python interpreted has a compiler in it. That's great. So these are the kinds of characteristics that we want to think about when we're talking about learning a programming language. Like I kind of mentioned in the introduction, I've had to write a lot of languages to prod in the past. And at one of the companies that I previously worked at, it was sort of expected that you would be able to get from 0 to being able to honestly bill at your normal rate on a new programming language in 2.5 to 3 weeks, which seems short, but when you have to do that 7 or 8 times, you eventually figure out a system for figuring out what you need to know about a programming language. So we're going to start looking at Swift, and we're going to ask some of those questions that I would typically ask when we're learning about a programming language. And as you keep track of these questions, I think you'll find that asking them again when we go back and learn Kotlin will be a valuable exercise in getting up to speed on the language quickly. So let's do this. In the GitHub, let me go ahead and share my screen with you again. Cool. Okay. So in the GitHub, we have this thing called firstswift.playground. I'd like you to go ahead and clone the repo and open that playground in Xcode. So I'll give you a minute to do this. And I'll show you what you'll see. Let me pull it up. Are we all ready? You can also private message me in the chat if you're not ready or you're having trouble, and I can either slow down or try to help you via private chat. Cool. So what you are seeing here is a playground, which is a type of file that Xcode can provide for us to create an opportunity for us to rapidly try things in Swift. 1 second. Let me just say this to everyone. Can y'all see my screen? No?
No.
Okay, hold on. What is going on? Let me try this again. What is happening? It thinks it's sharing. That's not right. Let's try this again. Can y'all see my screen now?
Yep.
Cool. All right, so what you want to do is you want to go to that session 1 repo inside of our GitHub organization. You want to clone that down, and then you want to open firstswift.playground. It's a file inside of that repo. Here, let me put the link in the chat to the repo. So if you've been given access to our GitHub organization, you should be able to go to that link and clone. While y'all do that, I'm gonna get my charger real quick. Cool. So it looks like a couple of you are downloading Xcode and some various things are happening. For this part of the tutorial, I think you can pretty much follow along. Most of the code is kind of written and I'll show you things line by line. For a little bit later portion of the class, we're going to be writing an iOS app and you'll want to follow along. But what we can do is, as you're downloading Xcode, and then at the break, I think we can take break before we do that iOS app, and then what we can do is you can kind of get up and running at that point. Does that sound good? So just follow along with this while Xcode is downloading, and then we'll get you set up ahead of doing the iOS app itself. All right, so what you're looking at here is some Swift. So let's talk about some of the characteristics of this programming language and the questions that I would ask about it before I would start working in a programming language. First, what you're looking at here is a playground. This is a REPL for Swift, basically, inside of the Xcode development environment. It allows you to run things immediately. So if I click this little play button right here, if I hover right here, I get a play button. And then when I click it, I get the answer, well, the return value over here on the right. So can folks see this? Everybody could see my screen? I like to check. Cool. All right, great. So how about Swift? What does it compile to? We talked a little bit about this. So Swift compiles down to machine code. It is designed to go onto the LLVM, low-level virtual machine, which was started as an academic project by this guy, Chris Latner, who now works for Apple on the Swift team. Surprise, surprise. And you don't necessarily need to know that to write Swift, but that project is a progenitor of something that you will be using a fair amount, LLDB, the low-level debugger, which we use to debug our programs when we're writing iOS code. So then what are its tokens and types? This is a good thing to know about whatever programming language it is you're writing. And so in Python, we have our integer, we have our double, we have our string, we have our lists, and we have our dictionaries. So we have those things in Swift as well. We're going to talk about each of those data types as we kind of go through them today. The first one you're going to see here is 10 here is the integer, but you're going to notice that it is not, you don't see int written anywhere. So it would also be possible, to say var 10 int like this, and then have 10 be equal to 10 like that. But in Swift, we have something called type inference, which means that if you assign something an initial value and Swift can guess what that initial type is, it will guess the initial type for you. So we see that with 10 here, and we also see that with 20 below. So if I run this line, and if I run this line, you'll see that those two values return right there. You can also do basic arithmetic operations in Swift. This is the same as it would be in Python, right? Now, let's try this. We're going to reassign 10, and this time we're going to assign it to a string, right? To the string 10. Swift's not going to let us. So let's take a look at this error. Cannot assign value of type string to type int. So up here, 10 could be whatever you want. If you assign it to 10 up here, then it will work. Or if you assign it to anything up here, then it will work. And the reason is that now it sees that as a string. But now this isn't going to work because your addition operator is not going to work on a string with an integer, like 20. So let's put all this back. Now everybody should be happy again. All right. So we tried reassigning 10, and that seems like, you know, we can't reassign it to a different type, but we can reassign it to the same type. Can we reassign 20 to the same type? We cannot. It says we can't assign 20 because 20 is a let constant. So I want you to notice something about these two lines up here that makes them different. This one starts with var. The token var means that this variable can be changed after it's initialized. When you use let, what you're saying is this is a constant. This cannot be changed after it's initialized. So if I were to change 20 here, like that, then this would work. So we can use those constants to initialize things that aren't necessarily going to change. And that communicates something to people about our code. If we have a constant that they're not supposed to be messing with, then that'll indicate that that's supposed to be that way. The idea behind Swift is to take the legibility of something like Ruby and give it the type safety of a language with more constraints. So we also see that in the design of programming languages like Rust. The idea is to use the language as much as possible to limit defects in your code. All right, so we talked a little bit about integers. Let's talk a little bit about strings. So we can initialize these two strings, 40 and 50, right? And then we can add them together. Now up above, when we changed 10 to a string, it didn't want to add to 20. But the reason for that wasn't that we don't have that addition operator in strings. It was just that you can't add two things of different types. So when we add 40 and 50, what do you think is going to happen?
Going to concatenate.
Mm-hmm. It's going to concatenate just like that. Good. So now we have this concatenated string. That's great. So let's stop for a second and think about what characteristics of programming languages we think we can peg for Swift right now. So first of all, it's type system, right? Does Swift seem like it is statically typed or dynamically typed to you?
Statically typed?
Statically typed,
Static.
Yep. It's a statically typed language, that's right. Because even though the type can be inferred, your type can't be changed after you've initialized something, right? Because of this type inference thing that sometimes kind of trips people up a little bit, but it is a statically typed language. It can just guess for you in certain circumstances what it is you get. All right, So then tokens and types. We've talked a little bit about what some of the types are. We've talked about integers. We're going to talk about some others. We talked about strings and our tokens. There are a lot of tokens in any programming language, right? But we've already talked about a couple. We've talked about var. We've talked about let. We're going to talk about some methods that you can call. We talked about arithmetic operators. So conventions, let's talk a little bit about conventions in Swift, because this is one of those things that folks get tripped up on a little bit if they're coming from a language with a different convention. In Python, we tend to use snake case to name things. So if I wanted to name this the number 20 in Python, I would do it like that, right? And in Swift, that'll work. And that's not the way we do it. In Swift, we use camel case. So for a variable like that, we're going to use little camel case, where there's a little t at the beginning of the number 20. If we were naming a class or a struct, which we'll talk about a little bit later, it's also camel case, but capitalized. So the capitalization conventions in Swift follow the capitalization conventions in something like Java, right? You've got your capital camel case for your classes, and you've got your lower camel case for your variables. So we've talked about conventions. Paradigm is an interesting one. We're going to come back to paradigm. So for now, we're also going to talk about precedence and associativity. Do folks know what these two things are? No? Does anybody want to guess? No?
How like operations are processed based on not having parentheses or having them.
That's right. Yep. That is what precedence and associativity refer to. So precedence says if you have a whole bunch of operations chained together with different operators, which operators come first? Let's look at this example on line 24. You see 30 plus 10, and you see 20 plus 20. And there's this division in the middle. What do you think is going to be the result of this 30 plus 10 divided by 20 plus 20 line?
I think it'll do 10 divided by 20 first, and then add 30 and 20.
And then it'll add 30 and 20. All right, let's give it a try. It's telling us the result is 50. Does anybody have an idea how it might have come up with that number?
Is it an integer?
That's right. So first of all, the precedence goes from the division operator first, then to the addition operators. So you were right on your guess on the precedence. It's like this. And so the result that you end up getting there is 50.5. But because this is an integer, it truncates that to 50. I put this note in here. You don't have to worry about this, but the compiler that Swift uses uses recursive descent parsing. This essentially means that it would take something like this. It would take this expression, and it would identify this kind of first as the most important thing, and then it would spill over and it would handle the two addition operators after that. All right. So now let's talk about associativity. Precedence is which of different operators come first. Associativity is when you have several of the same operator. How is that evaluated? So you have something like 30 divided by 10 divided by 20. What do you think the result of that's going to be? In this case, this was probably not a good example. Yeah. So the reason this is not a good example is because you have 30 divided by 10. So you get a 3, right? And then it's divided by 20, and it's a really low number, and it truncates to 0. So this is not a good example, and I apologize for that. Let's do this instead. Hmm. I'm making things up. There we go. So that 18 divided by 3, that'll give us 6, right? Divided by 2 is going to be 3. This seems like a silly, kind of nitty-gritty thing for us to be thinking about. But a lot of times, if you've got a bug in some arithmetic or a bug in some kind of like distance calculating algorithm or something that you're working on, it ends up being something like this, where you assume that the precedence or the associativity in the language was one thing and it was a different thing. And I think this is important to talk about because it isn't necessarily what you think it is based on knowing the language. So we have these things called precedence and associativity tables, which we can look up for a programming language, which will tell us. Most people don't really bother to look them up. We just use parentheses to make things ultra clear. But there are some surprises. So for example, the associativity of division operations in Python is left to right. The associativity for multiplication operations in Python is right to left. It doesn't matter because when you multiply things, you can do it in whatever order, right? But that's weird, right? Their associativity for these two inverse operations is left to right versus right to left. I can't answer why. I don't know why it's that way. I just know that it is that way. All right, so we know what precedence and associativity are, right? Let's, whoa, I lost y'all. You're back. All right. Okay. So now let's talk a little bit about a couple of things that you can do in Swift. As with any language, a number of the types come with their own methods that you can go ahead and call on them. If we want to uppercase a string, we can call this uppercase on it. And then if we wanted to make it lowercase, you have the method there. This is one nice feature of the Xcode IDE is that when you put a dot, it will attempt to autocomplete things for you. So in this case, I put .l. It looks up all of the things that could be called on 40.uppercase that start with L. And lowercase would give us our lowercase 40 back. But we could also go with, let's see what else is on this list. There we go. Let's see what this gives us. So one thing that I will frequently do if I am working on an iOS app and I want to figure out what attributes are available to me on an object or something like that, or I want to figure out what the options are, I'll use auto-completing to determine what I can do. And I'll also look at the documentation for specific types and specific classes. We're going to talk a little bit more about how to do that when we get a little further into the IDEs. Don't worry about it for now. All right. So now you've already seen the result of this a little earlier, so we're ahead. But what's happening here is we have a string where we want to say the price of the book is $10, but we can't right now because 10 is an integer. So what we need to do here is figure out how to interpolate an integer into a string. We can do string interpolation in iOS or in Swift rather with this syntax. So let me, it does not want me to run things until I have this commented out. So it's a slash like this, and then these parentheses. And that's how you interpolate a string in Swift. So you'll see this used when we're making labels and stuff like that inside of iOS. So we want to get something to display on the screen that uses a number. All right, we talked a lot about types. Let's talk a little bit about logic. You'll get into some of this a little bit more inside of the guided tour of Swift, which you're going to see on the homework. But Suppose that our book price is 10. We know that this is going to be, what, an integer that's $10, right? And so we have our conditional logic that works like this. So we don't have to put parentheses around our conditionals in Swift like this. We can just write it this way. If the book price is greater than 15, then print something, otherwise, no. We use these curly braces rather than end values or something like that, like we might do in Ruby. And unlike Python, so Swift is white space independent. So in Python, you're determining where things start and end based on white space, not in Swift. So I could put this up here and it would work. It would look gross, but it would work. All right. That having been said, it's conventional and good practice to do it like this because people can read that a little more easily. Cool. So this is if and else you might be familiar with, right? Now let's talk a little bit about switch statements. I'm going to uncomment this and we're going to get an error. Now this is another cool thing about Swift is that it's checking, for example, to ensure that things like our case statements are exhaustive. So what do you think it means by the switch must be exhaustive? Any ideas?
It's got to be able to handle all cases.
Mm-hmm. It's checking that it handles all cases. And in this case, it doesn't, right? Because anything other than 6, we don't know what has to happen. Let's take a look at this one down here. It seems to be happier about this. And it's happy about this one because we have added this token called default, which means if the price is between $0 and $6, then we have something to do, or if it's between 6 and 10, we have something else we want to do. Otherwise, we'll print better be a good book, right? This right here, these 3 dots, this is called a range operator in Swift, and it's how you can say I want something to be between these 2 numbers. All right.
Is it inclusive of 6? So like 0.6? Is that inclusive of 6?
I believe it is exclusive of 6, but we can check. Let's take a look. Let's do that. Yeah, so it looks like it's inclusive of 6.
But then does it, I guess it doesn't include 0?
Good
Because otherwise, how would it know not to go to the second case?
Good question. Looks like it's inclusive of both. So I wonder then if I do this, will it be upset with me? I suppose it won't. Weird. I'm going to have to find out why that is and get back to you, because that seems like it shouldn't be the case. I feel like these should be mutually exclusive, but I'll figure that out. Good catch. Book price.
Is it stopping on the first case and it's just finished after that?
So theoretically, that's a good question. It may just be stopping on the first case. I don't want to answer definitively because I'm not sure, because the way that case statements like end up getting executed depends on the programming language. So I'm going to look this up and I'll let y'all know. But in fact, let me write a note about that, just in cases. Cool. All right. So what I'll do is I'll put an issue in our GitHub thing and I'll answer that question. That's a good question. I'm not sure, but I'll go find out. All right. So we can also do, we can do greater than or less than. We can also do greater than or equal like that in Swift. So we have these equality operators that we can use. which is exciting. All right, and then we also have less than or equal here. So let's return to what we've learned so far about type inference. What if book price, if we're checking this, what type do we think that enough money is?
Integer.
It's an integer?
It's a Boolean.
Oh yeah, never mind. Boolean.
Yeah, it is. It's a Boolean. It's easy to get tripped up because we're talking about integers here. And if we stopped right here, if we were adding two integers, it would infer to an integer. But here, we're checking whether something is true or false. So it is a Boolean.
Is there a way to write Booleans? Like I know in Java, usually you say like is something. But is there any like special way to write it in Swift?
Yeah. So let's talk about that now. How would we print that we want to purchase both the book and the latte if we have enough money? Well, we have a few options, right? We could say if enough money is true, print, right? So we could do that.
Well, what I mean is the actual variable name. Like, is there a way that variable names are typically written for Booleans? Like in Java, it might be like is enough money.
Oh, I see what you're saying. So in this case, you wouldn't typically, but what you would do colloquially is this. So you're not equating it to true, you're just using the variable name itself. Is that what you mean?
I think you answered it.
Okay. So, okay, if you are switching on a variable in your code, this is a colloquial way to do it. This will work, but it is redundant. So please do not. All right, so we've talked a little bit about Booleans now. We're going to talk about some of the more complex types. So we'll start with arrays. So here we have an array of books, and they're not very complicated books. They're just strings with the titles of books, right? So we get that array over on the right side. We can add things to arrays like this. Now, the way that we assess the length of arrays kind of depends on the language. We use length in Python, for example. We use count in Swift. When we iterate over arrays, we can do it with the index the same way that we would have done in like Java 5, for example. But this isn't the way that we would typically do it. So we have these indices, and we know that if we can index like this in Swift, and that'll work, right? But typically we don't use the index. Instead, we use what's called for in syntax, right? And so we've seen this in Python. We see this in modern Java. So this is the way you want to be iterating through an array, unless you need the index for something. Does that make sense? Is everything clear so far, or is anything still murky? So far, so good?
I have a general question.
Yeah.
You said that there's like some certain things that you look for when you're learning new languages.
Mm-hmm.
Do you have like a list of those things, or is that what you're going through now with these comment pieces?
Mm-hmm. So in the lecture notes, there is a list of things. There should be, if you go to the repo, let me show you this again. It says here are the lecture notes for session 1. And if you'll click on that, you'll get this document open, which contains the lecture notes. And then if you scroll down to characteristics of programming languages, you'll see that list. Is that what you're looking for?
Yeah, thanks.
Cool, cool. Cool, cool. All right. Let me get over here. All right. So now we're going to talk about another data type. This is a dictionary. Here's how I want you to think about dictionaries, because people think of dictionaries as being more complicated than arrays, and I don't think that that's an accurate way to think about them. So in an array, we have a pointer, right? That's usually an integer that points to something. So for example, in books, 0 points to the 1 device. 1 points to crafting interpreters, and so on and so forth through the indices, right? So a dictionary is an array, except that instead of being those integers, the keys are just arbitrary. So they can be integers. So in this case, we have a dictionary where your keys are 1 and 2. They're integers, right? And you could use one of those integers and you could get something out. That having been said, you can also make your keys strings and put some kind of value there, and then you can get a hold of that value by using the string. Arrays and dictionaries have a lot of the same logic in them. The only difference is that the index is an integer that is given deliberately in the array, and it is more of an arbitrary value in the dictionary.
Do the keys have to be of the same type in a dictionary, or could they be
Keys have to be
interchanged?
the same type. I believe they do. We can test that though. Take a look. Yeah, heterogeneous collection literal could only be inferred. That is quite the error message, Swift. So heterogeneous collection literal could only be referred to as any hashable to int. Add explicit type annotation if this is intentional. So it looks like it can be heterogeneous, but you have to explicitly have things conform to a specific protocol to make that work. We are not gonna, you'll get these kind of like fixed things in iOS sometimes. We'll go over how to tell which of those is a good idea to click and which one isn't later.
I might have missed this. Why does it say why programs fail in the for books in books?
For
Oh,
yeah.
line 94. Oh, okay.
Yeah.
It
Oh,
just appears
this,
very.
because this is an odd, this is a quirk of the REPL where it prints out, like what you're seeing is the print value of the last thing, and I'm not really sure why that happens. But that is not like supposed to be functionality of Swift. It's just a weird rectangle that has now been inserted into the. All right. All right, so we talked about the capitalization convention in Swift already, but you kind of see it at work here, right? All right, and then let's talk a little bit about iterating over dictionaries. If you're doing this, the dictionary might not necessarily be the data type that you need, unless there's something else going on where you need to be using it. But there are some cases where you're using like a dictionary to store some data, and for some reason the key is meaningful and you need to iterate over it to get a hold of that. And so this is how you would go about doing that. You can make a tuple of the key and the value, and you can use the same for in syntax that you would use with an array. Does that make sense? Cool, cool, cool. All right, finally, This is the last thing we're going to talk about in this little intro to Swift. It is by all means not everything that there is to know about Swift. We're going to keep talking about stuff that you can do in Swift throughout at least the first half of the quarter, and you're going to learn some more in your homework. But in terms of like how much you need to kind of get to the next part that we're going to do with iOS itself, this sort of understanding of the types is really what you need. The last thing you need to know about is optionals. So have folks seen optionals in other languages yet? You can unmute or put it in the chat or whatever you want to do. I know that Java has them. Modern Java's got optionals. JavaScript, okay. Places where you might not necessarily see this would be, for example, in something like Ruby, it doesn't necessarily like check whether a value is there or not for you. It'll just let you access things and then blow up at runtime if the value isn't there. But if you've written a lot of Java, then you'll be familiar with the colloquialism NPE, the null pointer exception, right? When you're trying to access something and it's null. So modern programming language are trying to figure out how to solve this problem of like, when are things supposed to be nil? When are they not supposed to be nil? How can we like forewarn of as many defects as possible without requiring people to put in default values where it doesn't make sense? And one of the modern approaches, and the one that Swift uses, is an optional. So in Swift, when we're talking about a value that could potentially be null, we indicate that like this. So say we have a favorite book, and the type is this string question mark. That means that we might have a favorite book, or it might be nil. And so under the hood, that looks something like this for the Java familiars in the room. Right? And so what you can call on this is a little bit different than it would be if you had a non-optional string. So we have a couple options for this. We have this optional. When we have this optional, what Swift is going to do is anytime something is an optional, it's going to ask us to make sure that value is there before we do anything with it, right? And in Swift, you will frequently see people naming optional stuff like this. They'll put maybe on the front. Maybe favorite book. Not always. I don't always do this, but that's popular. You will see it. All right. Okay, so there's a couple of ways to check if something is nil before we want to use it for something. So say we want to say my favorite book is whatever, provided we have a favorite book. We can run this conditional thing that we've already done and say if favorite book isn't nil, then print this, and that'll work, right? Now, the thing is that here we haven't set favorite book to something. So somebody have a favorite book they want to throw out? You don't want to hear my favorite books. They're too nerdy. We're going to put in, you know what, we'll put in something I read recently. There's a book about a lawyer who like travels around in a van and defends people who no other defense lawyer wants to defend. So one thing we shouldn't need is this on the end. Value of type string must be unwrapped. So this is interesting. So it turns out that when you do this, it doesn't necessarily unwrap it for you, right? So this is our opportunity to talk a little bit about scopes, okay? So the scope refers to the region of code for which a variable is viable, right? And that's important here because what we see is that we're checking up here that favorite book isn't nil, right? And then we get in here. And we try to access favorite book, but favorite book here is referring to that, which is still an optional, which this piece of code doesn't necessarily know is there. And so even though I have it inside of this conditional, it's asking me to unwrap it. This is what you're going to get. This is the error that you're going to get when you have an optional that you're trying to access. Value of optional type must be unwrapped to a value of type, whatever the not optional version is. We see a couple of options here, right? Coalesce, using this. That means to provide a default value. So we could say, we could do this. And what that means is that if favorite book is available, then I don't know what to put here. The instant, here's what I have. This is literally, this is where I got this book title from that I'm about to type in. So this was given to me when I got an Instant Pot. So that means that whatever that means that you could set a default value. Why is it still unhappy? Let's do this. That's weird to me. I would think that the precedence would work. What is happening to me? Oh. Okay. So now we have this like default that we can use, right? So let's look again at what it says. It gave us two options, and I want you to see both of those options. So so let's go back to having this be favorite book. So we had two options here. One of them was force unwrap. So we're gonna go over this in a second, so I'm gonna leave it, but I wanted you to see that it was one of the options. All right. So comment that out again. Let's talk about force unwrapping. All right, so in this case, we don't know whether we have a favorite book or not, but we have this exclamation point on the end. What that means is, trust me, I know what I'm doing. I know the value is going to be there. Now, this is valuable if you, in fact, know that the value is going to be there. But if you don't know the value is going to be there and then it ends up not being there, then you run into problems. So let's, here, this is why this is happening. It's not related. Right? So we get this error. Execution was interrupted. The process has been left at the point it was interrupted. It's a little bit strange looking. Essentially what this means is that you unexpectedly found nil while unwrapping an optional value. So here you said, don't worry, I know what I'm doing. I have a favorite book, but you didn't. Whereas if you had, then this would have worked. So you want to use this only in very specific situations. We're going to see a situation with iOS today in which you kind of have to use it, and we're going to talk about that. But in general, if you have an optional value, before you do this, you want to try an alternative method. And so we're going to talk about the alternative method now. It's called optional binding. And so this is where we're going to come back to our conversation about scopes from up here. Because up here, remember, we had this scope and we said favorite book, if favorite book not equals, no, this is how you would do it in Java or something, right? And to avoid your no pointer exception. But the problem is because Swift is using this optional and it doesn't want to allow you to just grab an optional value like that and use it, then you can't. So what you need to do is you need to create a variable that inside of the scope of this action, Swift knows is there. And that's what we're going to do with this optional binding syntax. So what this says is, if favorite book exists, assign it to confirmed value. And this variable inside of this scope is guaranteed to exist. If favorite book doesn't exist, then this whole clause is going to get skipped. Does that make sense? Are there questions about that?
Yeah, so is it essentially saying you're trying to set confirmed value to, let's say, favorite book doesn't exist, it's nil. So would that mean confirmed value equals nil? So it just checks if true, false. And in this case, since it's nil, it equates that to false?
It would not. So the way that this, well, let my brain finish processing what you said. I think so. The way that it works is that you attempt to do this assignment, and if favorite book is there, then this statement evaluates to true, which if then runs. And if this is nil, then this statement evaluates to false, which if does not run. That's
Okay,
what you said,
thanks.
right? Yeah.
Yeah, it makes sense.
Yep. Also worth noting, outside of the scope, confirm value no longer exists. So here you see it's not auto completing it for me. It doesn't exist here. So that only exists in the context of this up here. Does that make sense?
Yep.
Cool, cool. So that's about as much Swift as you need to know in order for us to start trying out some iOS stuff. I made very minimal changes to this file, but I will commit those changes and I'll push them up after class so you have access to what small changes I did make. Most of them were formatting. A couple of them might have been adding a comment here and there, but a lot of it was just commenting and uncommenting things. So you'll have this for reference. And like I said, you'll also be doing more Swift in the guided tour later. All good so far? Cool. So my plan at this point was for us to go right into developing our first app for iOS. But I know that some people needed to download Xcode and then they needed to clone down the repo and open it in Xcode. So what I think we might do is take the 8-minute break now and let folks do that and then start off with the iOS app after that. Does that make sense? Fantastic. So what we're going to do is we're going to take an 8-minute break. This will be the last full-on break, but there will also be like an independent exercise later that you can do. And so this isn't the last time that you get like time to think without me talking at you. Sound good? All right, so let's come back at 7:20. How we doing? Good. So it's funny, the reason that the breaks are 12 and 8 minutes is that the last time that I taught, we started out with one 15-minute break halfway through class. And we determined that in 3 hours, it's still difficult to have two 90-minute classes like right back to back like that. And so we turned it into two 10-minute breaks every hour on the hour. But I taught in Ryerson, and it took the students just slightly more than 10 minutes to go like get something from ABP and come back. And that's how it became 12 minutes and 8 minutes. But I guess that's not necessary now because people don't need to run to Ryerson. But we can play with the break length over the course of the quarter and figure out what to do. You're all excited to write your first iOS app? Yes, a little bit. Old hat. I know a couple of you have done some tutorials in the past, and so this won't be completely new to all of you, but it will be new to most of you, pretty new to most of you. So what I'm going to do is in Xcode, we're going to bring up Xcode. Xcode is the integrated development environment that you use for iOS, and this time we are going to actually make an iOS app. So let me share my screen with you again. Desktop 2. I have to figure out a good situation so I could look at y'all without having it. Y'all have to see. We'll figure it out. Maybe I'll stick a camera up here. Okay. Can people see my Xcode screen where I have the My Favorite Book code up? You can. Rock on. Okay. When I'm sharing my screen, it's really tough for me to look over and see the chat. So feel free to just unmute and ask questions and then mute yourself again when you're done. Y'all have, I must say, excellent mute etiquette. So that is a relief for me as an instructor. So thank you very much. So here's what we're gonna do. We're in Xcode. You can see on my top bar here. And we're gonna hit File, New, Project. Everybody see that? Or you might be on this like pop-up in the middle of the screen where you can still click New Project. So click on that. You're gonna get this. Y'all see it? So we have a number of different apps here. There's some really cool stuff in here. We're not gonna touch any of it today. We're just gonna use single view app. We're gonna make an app, and I'm gonna call this app Lights App because we're literally making it a light switch. What's up?
Could you repeat on which file we are doing this?
From which file? Sure.
Yeah.
So you're gonna go File, New, Project. Do you see that?
Yes, sorry. This is the same file we have been working before the break?
No, you go to the, sorry, you go up on the top where it says Xcode File, Edit, View, Find. You'll go to File in that menu.
Perfect, thank you.
And then New. Yeah, totally. Cool?
Yeah, thank you.
All right, awesome. Single view app. So I'm gonna name this Lights app. It's gonna live. It's gonna ask you where you want it to live. I want mine to live in session 1 because I'm gonna commit it so you can see it when we're done here. It's gonna take an inexorably long time to load. Xcode is many things. Fast is not one of them. Stable, also not one of them. However, it's good at some things. We'll get to it. I actually don't hate Xcode as much as most people do. I know Sarah loves.
Can I ask a question?
Yeah, totally.
Yeah. So what you need to do? Do we need to do like team or organization identifier? Because I cannot go on to next.
What do you mean?
So I just type in the product name, which is Lights App, and then do we need anything else?
You need the organization identifier.
Oh, organization identifier. All
and you
right.
can just make one up.
Yeah.
Okay, sure. Yeah, that makes sense. Thank you.
It works? Rock on. Thank you. Okie dokie. All right, so you're going to get taken to this, to where you can kind of see this information about the app that you've written so far. Congratulations, you've made your first iOS app. Good work. Stick it on your resume. So let's talk a little bit about what we're looking at. Does everybody see some version of what you see on my screen here? I know it's tough if you don't have two screens to like look at what I'm doing and look at what you're doing. Okay, so let's talk about some of the stuff in here. We've got this display name, that's the name of your app. Your bundle identifier, which is going to take your organization identifier and put this on the end of it. If you're working for a company, this will be like Pivotal or something like that. Your version's always going to start out at 1. You can say whether you want it to be on just the iPhone or just the iPad or both. For now, we'll leave it at both. You can also lock it to just portrait. So if you don't want to have to deal with landscape views, then you can do that. Generally, upside down comes unchecked. And then there's some stuff about icons. We're going to talk about icons later. Okay, so this is sort of some information about your app. Let's talk about some of these toolbars. So over here on the left, you have a bunch of toolbars available to you. And the one that should be open right now, it says Lights app on the top with a blue thing next to it. And then you see Lights app with this little folder next to it that you can open and close like that. This is called your target. So this is your app target. And if you close it, you see Lights app tests. And this is your test target. So we're going to talk more about your test target later. First, we're going to just write an app. Inside of the Lights app target, you're going to see a bunch of files, appdelegate.swift, scenedelegate.swift, etc. I'm going to talk some more about these later. So that's your project view. You can hit Command 1 and always get to that. Now I'm going to speed through some others. You don't have to know these, and they'll be recorded, so you can go back and look at them later. Command 2 is going to give you your view of all of your version control stuff. You could see it right here. If you hover over this, you'll see your product view, and then you can also click on them. So here's your source control navigator, your symbol navigator, your find navigator, issue navigator, test navigator, debug, etc., etc. So you can go through these like project is Command 1, version controls Command 2, then you have Command 3, 4, 5, etc. So the ones that I find myself using the most are this one, the Finder, if I need to find some text in my app, or I'll look here for the issues and warnings in my application. We'll go over that later. I can look at my tests here in my test view, in my test navigator. And then I can also look in my debug navigator if I've set breakpoints. We're going to go over breakpoints a little bit later, so don't worry too much about that. All right. So you have your view controller here. This is where we're going to put code. But first, let's take a look at our screen. So I want you to click on main.storyboard. Do you see that file? You click main.storyboard.
Can I ask, is it a problem if I don't have main.storyboard? The only one I got is the launch screen.storyboard.
So do me a favor, do Xcode, do file, new, project, single view app.
Right.
Okay, do you see where it says user interface?
Oh, yeah.
I think the very new, like the latest Xcode, unless you reset it, it defaults you to Swift UI.
Right.
But I want you to start on Storyboard.
I see.
So we're going to go over what that, I apologize, I should have specified that. I didn't realize that that folks were going to be using the one that defaults to Swift UI.
Sure, I'll just run this again. Thank you.
Yeah, no problem. So do we all have a storyboard? We can click on main.storyboard. So we can go over how to change this default in the settings in a little bit. But for now, we should all be making a storyboard app. So this is your storyboard. And a storyboard in app building means a similar thing to what storyboard means in comic building. So you're going to be able to see all of your different scenes on this screen. Now, we also have a toolbar. We have this toolbar on the left that we went through where we can search for things and we can debug and we can look at our tests. We also have what's called the Assistant Navigator over here on the right. And you can see a couple of different things in there, right? We have, hovering over these is a little bit hard. So you have your History Inspector, your Quick Help Inspector, your Identity Inspector, your Attributes Inspector, your Size Inspector, your Connections Inspector, and your File Inspector is the beginning one. So if you click on your Attributes Inspector here, and then you click on your scene here that looks like an iOS screen, you'll see a content mode, semantic, tag, some things that indicate the attributes of the screen that you're looking at, right? So you have your system background color here, right? And it defaults to white. But if you were to set that to some other color, it would set your background to that color. You all seeing that? Cool. So let's set that back to your default. Let's set it to white, not default. All right. So now let's take a look at our Identity Inspector. It looks like a little newspaper right in the middle, up on the top right there. So you'll see some things in here that we're going to use later. You'll see we have our class, we have our module, label, stuff like that. You'll notice some traits down below. User interaction enabled should be checked. That means that folks can tap on your app and that kind of thing. Cool. All right, so this is sort of your initial screen. Now what you're looking at right here is an iPhone 11. And the thing about the iPhone is that it comes in several different sizes, which is going to change the way your screen looks, right? And it can also have different orientations, right? Which also change the way your screen looks. So it might make sense while we're developing our view to be able to see several of those at once, just to check ourselves and ensure that things aren't going to look weird, right? So up here in the top area, so you're going to see a bar on top that says Lights app, main.storyboard, some other stuff, right? And you're going to see this thing that looks like some lines. And when you hover over it, it says Adjust Editor Options. Do you see that? I want you to click on that. And then you're going to click on, which of these things is it? So you should have preview. Let me see if I can get it to display. So I'm trying to get to this preview option right here. I'm not quite sure why it's not available for me. So now you'll see that my lines here changed. Preview was not, it was grayed out for me, but then I hit the key binding. I hit Command Option, or not Command Option Enter. Yeah, Option Command Enter, and it opened up for me. And I'm not sure why it was disabled because then it works when I use the keyboard. But if preview is enabled for you, you can click it in here. And if it's not, you can hit Command Option Enter. And apparently it works because things being disabled doesn't necessarily mean you can't access them in Xcode. You're going to have a healthy distrust for Xcode by the end of this class, I promise. I'm not trying to do that to you. I'm going to try to be very sympathetic towards the editor. It does some amazing things. It does some not so cool things also. Okay, so down here in the bottom, What I'm doing is I'm taking my fingers on my trackpad and I'm moving them apart and together right here, and I'm zooming it in and out. And so you'll see that we have an iPhone 11 there, right? So in the lower right-hand corner, there's a rectangle with a teeny arrow. It's a little hard to see, but it's right there in the lower left-hand corner. And if I click it, it's going to rotate the orientation of that device for me. So now in my storyboard up here, I could see it in portrait mode, and then down here, I could see it in landscape mode. So this is going to allow me to see, as I add things to my screen, what they would look like in portrait and also in landscape. And I can add other screens too. So in the lower right-hand corner of the assistant editor pane, I can add an iPad Pro, for example, right? So I could see what it looks like on an iPad Pro. And then let's also add a teeny phone. So we can make sure it looks good on a teeny phone, a really old iPhone 4S. So now I got some stuff here, right? And I'm going to be able to see the way my app looks on several different devices and orientations at once. You could add a lot of things here. I'm just going to add 3 because that's kind of what I could see right now. And now we're going to add something to our screen. So what you're going to do is you're going to hit Command Shift L as in lion. And that's going to bring up an object library for you like that. Okay, so you got your object library, and I want you to type in switch. We're going to be making a light switch app. So we're going to need this switch. So what you want to do is you want to grab that switch, you're going to click it, and you're going to drag it onto your screen. Try to stick it in right about the middle. It's going to show you the middle with these blue dotted lines. So when you're done, you can drop it.
Sorry, I can't see that switch. I have just like the code when I do Control-Shift-L.
Me as well.
When you do Command-Shift-L, you only get code.
It's launching something called snippets.
Are you doing it with Control or Command?
Command.
Sorry, Command. Yes, it's. I can see almost the same pop-up that you saw.
This one?
Yes.
And so what you're seeing is not the same.
I type switch, and on the right side, I see like a code, I guess a code for a switch.
Interesting. Do you see switch on the left here?
Yes, but not with that green icon.
Weird. I might have to debug that individually with you after. I'm not sure because I'm not quite sure what's happening there. So what I'll do is, why don't you keep following along with the recording, and then we'll link up one-on-one and figure out what's going on with yours. Does that sound good? Okay. Is anybody else seeing that same thing? You're seeing the same thing?
Yep.
All right. Let me chat with y'all at a separate time and figure out what's going on with that. Does that sound good? Okay, okay.
I think it actually is dependent on what you have selected at the time, it looks like. So if you click the one where, like if you clicked below, like when I had it selected as the one where you can view as iPhone 11, it was launching snippets. But when I kind of had the other pane highlighted and did it, then I got the objects.
Oh,
browser.
I see. You're clicking with these previews down here. Well,
Yeah, so that one was working when I clicked there. It just did something different based on what was selected on the screen at the time.
interesting.
Yes, completely true. Now clicking on the main iPhone that we had at the beginning.
It worked?
Yes, thank you.
Interesting. I had not seen that. Hold on. All right, I'm going to look at that. Thank you for bringing that up. But now you're getting what you need to get? You're able to see the object library?
Yep.
Okay,
Yes,
cool.
perfect.
Awesome. So y'all put this switch, you dragged it right into the middle here. Oh gosh, what happened? Okay. You dragged it into the middle, and it's in the middle on here. But then if you look at your landscape and your iPad and your smaller phone, it's not in the middle, is it? Does anyone have any idea? Do you think you might have an idea of why that is?
Is it just guessing where you want to put it based on like if it's a bigger screen size?
It's close. So what it's doing is, the way that iOS determines where to put things on the screen is with information you give it called constraints. And we're going to talk about the different kinds of constraints that you can use, but if it doesn't have constraints, what it does is it calculates it based purely on how many points from the top and how many points from the left it is. And so it's the same number of points from the top and the left on all three of these screens, but on a big screen that doesn't get anywhere close to the middle. And on this landscape screen, it goes down below, so it's somewhere over here. And on this tiny screen, it gets almost all the way to the bottom because this screen is so much bigger. Halfway down this screen is almost all the way down the small screen. So we have to tell iOS, no, we want this in the middle on all devices. So the way that we do that is we click on our switch, and then in the lower right, you're going to see this thing that looks kind of like a bar chart. You're going to click on that. And it's going to say add new alignment constraints. So in this case, we want to check the box next to horizontally in container. That's going to set the constraint that says this should be horizontally centered. And we're also going to check the box that says vertically in container. So this is where it's going to be vertically centered. And we'll click add to constraints. So now what you should see is that it becomes centered on all of the screens. You see that? Cool. There are a lot of different constraints that we can set. This is one of them. We'll go over some of the others a little later, but now you have kind of an idea of what constraints are meant to do. So if we were to try to run this app, we could hit the play button in the upper left-hand corner, and that's going to run our app on this thing called the simulator, which packages up with Xcode. And what that's going to do is it's going to simulate an iOS environment on your machine so that you can see what your app looks like. It'll take a minute to fire up. Let me make mine a little smaller so you can see the whole thing. And it has a switch, and we can move the switch. It doesn't do anything, but we can move it. That makes sense so far? So far so good. Now we need to actually hook this thing up to some code to get it to do something. And so what I'm going to do is I'm going to hit Command-Shift-O, which means open file. I'm going to type in view controller. So I see view controller.swift. And then I'm going to hit Option Enter. And when I do that, it's going to open this on the right side. And it's going to keep showing me my main.storyboard on the left side. You don't have to do this. I just like to be able to see everything at once. Sometimes this gets way, way too busy. And so I can come up to the upper right and I can close some of the other editors. So that closes the editor on the right. This closes the editor on the left. This closes the editor on the bottom. So now I can kind of see things a little better, right? All right, so what you see here is the code behind the launching of that first screen. It's called a view controller, and it inherits from a class called UI view controller. In Swift, this is how we say I'm making a class. This is where we put the name of the class. And then this is where we put inheritance from a superclass or conformance to protocols, which we'll go over later. They're similar to interfaces. So this is our superclass. And this method is called, after the iOS